Hey guys, BuildZoid here, and welcome to the HWbot score roundup number 21. We've got some epic benchmark scores to look at, so let's get right into it because I've given up on trying to figure out an intro for this. So, the first score we're taking a look at is Psycho's SuperPi 32M world record, which is, like, the crazy thing is we had a SuperPi 32M world record, like, literally last roundup, and now we have a new one. On an even insane, like even higher clocked 11900K. So for comparison, the old record from OGS was on an 11900K doing 7.125 gigahertz, which is insane for an 11th gen chip because 11th gen has really big cores that don't clock as high as 10th gen cores did. And so, as you can see, like so far, 11900Ks have basically been hitting a brick wall a little bit past 7.1 gigahertz. And Psycho over here has managed to push an 11900K all the way to almost, like, it's almost 7.2 at this point. It's at 7174. And SuperPi 32M is a single-threaded, memory latency intensive benchmark, and the thing is, like, having a clock speed advantage is a really big deal in this benchmark, assuming that you also have your, like, software somewhat decently set up. On 11th gen, luckily, you don't need to run the benchmark on Windows XP anymore. Psycho is using just Windows 7 here with Benchmate, and Benchmate actually gives you some extra tweaks for SuperPi that you can do without it, but I think they're more convenient through Benchmate. Yeah, and so, like, what's really cool here is that definitely the score is being carried by the CPU clock speed here, as the memory is really not that impressive by DDR4 memory overclocking standards. That's just 4000 CL12. And even Psycho himself is actually complaining about his memory controller apparently not playing well with the memory sticks. So that's kind of interesting because those are G-Skill Ripjaws 5s. They should be, like, yeah, like, I wonder why they'd be having issues, but either way, 4000 CL12 is still a very low memory very low memory latency memory overclock, and that's in Gear 1, which these kinds of overclocks work on LN2 in Gear 1. The on-core frequency is at almost is at 6.34 gigahertz, which is also pretty high. I think it's a bit lower than what OGS was running. But basically, like, the thing is, the uncore is literally there just to pass data from the memory controller to the cores. So as long as it can do that well enough, it doesn't, like, it's not critical. And yeah, OGS had slightly more uncore frequency, but you basically, like, the uncore just needs to be capable to keep up with the, like, memory demands of the CPU cores. And as soon as it does that, it's sort of, like, it starts tapering off in terms of performance gains until, well, in some scenarios, it'll just do nothing. So, yeah, not really, like, it's not too surprising that, like, a 50 megahertz core clock advantage is more important than, like, a 40 megahertz. Actually, I think it's roughly a 50 megahertz uncore clock advantage. And on that note, also the memory, because I think OGS was running 4200 CL12 or 4300 CL12. Oh, yeah, okay, 4320, 4330 CL. Yeah, that's 4. Am I misreading that? No, that's 42. No, it's 4330. Yeah, it's 4330 CL12. So, yeah, OGS was absolutely, smashing it on the memory settings, but, like, at the end of the day, when the data gets to the CPU still needs to actually process it, and that's done with the core clock. So, yeah, Psycho managed to get into first place. Though I imagine his score would be even higher if, like, he had the memory, like, if the memory was being more cooperative. Or maybe his, like, CPU's memory controller just doesn't like to go very fast. And you also sometimes, when you start pushing the limits of a CPU or a memory controller, you start running into sort of weird issues, like you can trade memory performance for uncore clock, or you can trade. I'm not sure if you would necessarily be able to trade core clock for uncore clock, but it wouldn't necessarily surprise me either if that was the case. Like, if you reduced the bandwidth demands of the memory of the CPU itself, the memory would come up because it's like, well, there's actually less load on it now because the CPU is slower. So you can get away with more aggressive settings, but yeah, still just an absolutely insane overclock, and it's really cool to see a world record actually done on, like, not Windows XP. Other than that, Psycho's also running 6 cores and 6 threads enabled, so you want to disable hyperthreading for SuperPi 32M because the whole hyperthreading system has a bunch of, like, memory overhead as just due to how it works. And the reason why Psycho's running 6 cores here is and not the typical 3 cores is because on 11th gen CPUs you do have per core overclocking, and so there is like the chips come from the factory with an indicator for which cores are supposed to be the best, but I would assume that, maybe on liquid nitrogen those indicators might not be super accurate, and it might be worth it to just bin through the cores manually, or Psycho's best core just happens to be core number 5, which would be the 6th core. So yeah, a really impressive SuperPi 32M run from Psycho here, and done on a Maximus 13 Apex with some Ripjaws 5 Samsung BDI based DIMMs from G-Skill. So yeah, this is probably the last 32M world record we're going to see until 12th gen launches at this point, because 12th gen is very likely to smash the 32M world record, or at least you would hope it would, because like it does support DDR4. So worst case scenario, if DDR5 doesn't work out for SuperPi 32M, you could just run it on DDR4, and then take advantage of the extra IPC of 12th gen, in theory at least. Anyway, next score we're taking a look at is Ralph's GPU Pi version 3.3 32 billion score. So this is, so SuperPi 32M calculates 32 million digits of the number pi using one CPU core, and this is a really old benchmark, so this is not the fastest way to calculate pi these days, but the thing is the benchmark has a very long history, so it's great for comparing just an insane number of CPUs over the years. People have run SuperPi 32M on CPUs that take hours to finish the benchmark, and these days we're talking about world records in the sub 4-minute territory. But anyway, GPU Pi v3.3 32 billion is calculating 32 billion digits of the number pi using your GPU. And Ralph ran this on an RTX 3090 Hall of Fame. As far as I know, he is supported by, Galax, Asus, and Thermal Grizzly. And he has the card absolutely screaming through the benchmark here. 2970 on the core, almost 3 gigahertz. And this is pretty typical for GPU Pi, because GPU Pi is a very interesting benchmark. Unlike most other GPU benchmarks, it literally doesn't care what your CPU is doing at all. It's completely irrelevant. It also doesn't care about your memory on the GPU, because this is a relatively, it's not a very memory-intensive compute benchmark. And so, one of the things you can do for GPU Pi on some GPUs is actually give up memory clock, underclock the memory to try get more core clock, because this literally only scales with GPU core clock. And the funny thing other than that is that not only does it only scale with GPU core clock, it's not even that heavy, because it is a compute benchmark and it doesn't use all of the graphics rendering related parts of a GPU, so it actually runs rather cool, and you can just hit insane clock speeds running GPU Pi. And so yeah, here we have a 3090 doing almost 3 gigahertz, where for most other benchmarks, 3090s are sort of around the 2800 mark, for 2800 megahertz core clock mark. But yeah, here we're looking at almost 3 gigahertz. Previously, the record was held by OGS with actually the exact same clocks. So I wonder what changed, because that's 1 minute 3. I guess it might just be rerunning the benchmark a bunch. Yeah, because on a 1 minute runtime, are they using the same? Yeah, they're using the same batch size, same reduction size. So you can actually tweak the benchmark to run a bit better on various hardware by fiddling with the batch size and reduction size. That's part of the sort of that makes the benchmark a bit more interesting than just max out your GPU core clock and call it a day, because that's basically what you'd be doing if you couldn't adjust anything about it, because it doesn't care about memory. It doesn't care about the CPU. Like this is one of the this is a benchmark you could literally run on like an FX chip and it wouldn't really care. It wouldn't care. Like it's not even wouldn't really care. Like this is a benchmark that I think the world record for GPU Pi is on like basically a this. And you might be like, doesn't that run into this is a world record run on literally 8 RTX 3090s, and you might be looking at this and thinking, doesn't that run into like PCIe bandwidth issues? No, it doesn't, because I mean this is on Epic, but like I've seen people get in the past you'd see people get the world record on literally GPUs with PCIe like 1x risers, because the benchmark basically loads itself into the memory of the GPU, and once it's there, it just kind of runs. And again, still doesn't even put that much stress on the memory. So yeah, this is a wacky one. Previously we've seen, I wonder what the 8 2080 Ti's were on. Oh, some kind of Xeon setup. The main issue with this benchmark is getting like a motherboard that you can fit all your GPUs in. Oh. There used to be a bunch of crazy like 8 AMD. Actually, I think there was a 8 290X setup. Yeah. Or maybe that was an earlier version of the benchmark. Anyway, so yeah, this is just a crazy benchmark, and yeah, Ralph has managed to max it out here. Also, you can see the crazy backplate heating system that he has on the RTX 3090 there. Because the funny thing about RTX 3090s is the GDDR6X actually, like, so normally when people think RTX 3090, they think, oh, the memory runs really hot, you need to get, like, cool the memory. On liquid nitrogen, there's the opposite issue. The GDDR6X really doesn't work properly if it gets too cold, and so you need to have a massive freaking, heating system for the card to keep the memory warm while the core is really, really, really cold. So that's what's going on with that massive copper plate strapped to the back of the card, and you have a heating element like Kingpin cooling Inferno backplate, Inferno modules attached to that copper plate. So yeah, and there's two of them because one of those modules wasn't enough heating power to keep the card happy otherwise. Yeah, and then other than that, we've just got water cooling on the CPU because the benchmark doesn't care about the CPU. So yeah, a very impressive run from Ralph here, and just an insane overclock on that RTX 3090. I'm surprised nobody's tried to downclock the GDDR6X yet, because I know for some of the other GPU Pi rankings, you see people running GPU Pi with like pretty heavily downclocked memory because it like really doesn't care. And so I'm kind of surprised we haven't seen that yet for GPU Pi to try push the core clock even further, though at the same time it might not really make a difference. So that might be part of that. Anyway, yeah, a very impressive score from Ralph here, so congratulations to him on that. And let's move on to the next score, which is Nom's HWbot X265, 6-core HWbot X265 4K. Running on a Ryzen 5 5600X at 5.85 gigahertz, producing 21.085 FPS, getting third place in the 6-core HWbot X265 4K rankings. And this is on a B550 Unify X motherboard, so the MSI B550 Unify X, running with some ZADAC Samsung B-die based DIMMs. So this is some like this is not a vendor you regularly see, but yeah, these guys make B-die based memory kits, so that's what we're looking at here. And yeah, 5.85 on the 5600X, but the memory overclock here is just insane. We're looking at 2400 14 14 14 28, which like especially on LN2, that's really hard to run with Ryzen, because the Ryzen CPUs, their memory controller gets very upset when it gets cold. And so yeah, 4800 CL14 is just insane to see, especially in a benchmark like X265, because X265 is quite a bit more It's quite a bit heavier than some of the other benchmarks out there in terms of memory stability requirements and CPU stability requirements. And so this memory overclock is just really, really impressive. At the same time, it is on a B550 UniFi X, so you know, like on the list of motherboards that you would expect to do these kinds of clocks, well, this motherboard is definitely on that list. Um, and Yeah, and then just 1.7 volts on the 5600X. Though, funnily enough, when I ran my Ryzen 5 3600 on the UniFi X, I didn't have much success with the memory overclocking at all. That probably is because I didn't spend too much time on it, and I decided to run Cinebench so that I wouldn't have to worry about the memory settings too much. But yeah, so this right here is just an insane memory overclock for X265 on LN2. Like if we look at the top score from SafeDisk, well, for one thing, SafeDisk mainly has a 100 megahertz core clock advantage. But then if you look at his settings, he's just running 3800 CL14. He is also using overkill mode, so that might be part of why he's running the reduced memory settings, because overkill mode makes the benchmark even harder on the memory than usual. But yeah, this is basically daily memory settings, just on LN2. I wonder if he's actually managing to run 1900 Infinity Fabric, though. Because you can technically keep the memory controller synced with the memory and then have the Infinity Fabric desynced. Like, that's a thing. So, yeah, anyway. And, still, though, like, a very impressive overclock from Noms here. And, yeah, actually, how much voltage was SafeDisk using? It's reading out 1.75 volts there. So I guess with maybe more voltage and maybe lower... The thing is with Ryzen, it's really about bringing down the temperature to get the chips to clock higher. Like, if the chip's too warm and you raise the voltage, it doesn't do anything. Like, your clocks don't increase. So, yeah. Still, a really, really impressive score and result, because third place in 6-core HWbot X265. This is a pretty competitive ranking. Right? Like, we have a lot of scores in this ranking. We have surprisingly few 5600Xs, though. Well, I guess it makes sense when the 8700K doesn't, it's not so far behind that, if you had an 8700K based score, that you'd feel like you have to rebench with the 5600X. Yeah, so a strong score from Noms here, and HWbot X265 4K, and so congratulations to him on that. And let's move on to the next score, which is Crazy85's Cinebench R20. Second place in the 14-core CPU category with an i9-9990XE, which is just a wacky CPU because, yeah, that exists, the 9990XE. Apparently, these are like super binned 9940Xs, or 9980XEs with the 4 worst cores disabled, whichever way you want to look at that. And at the same time, no, I guess, well, with Miller hitting 5.5 max, I don't think that's... The thing is, I've run Cinebench R15 on the 7940X, and there you'd expect higher clocks, but the thing is, R20 is a lot longer, so I guess that makes it a lot harder, especially on these HEDT CPUs, which get so freaking hot. Yeah, especially at 1.45 volts. Actually, this is 1.47, so these chips just spit out so much heat that it just makes them very, very hard to run. And yeah, and this is running on a Asus ROG Rampage 6 Apex, with the memory just doing 3600 CL16, which... And Encore apparently... I think his Encore is at idle. I hope that Encore is at idle, because 2.4 gigahertz... Well, it's Cinebench, so it probably doesn't matter that much, but... Yeah, that is really low Encore clock. Honestly, these memory settings are kind of like X299's memory controller isn't amazing, but this is really... Yeah, that's like XMP right there. At the same time, Cinebench shouldn't really scale with memory settings that much, but it does, like, the thing is, on AMD, it basically doesn't care at all, but on Intel, you do see some improvements from actually pushing the memory a bit, so, and when I say a bit, I mean a bit, like, you don't have to go crazy on it, like you do for, say, SuperPi or Geekbench or some of the other benchmarks that, you know, are very memory intensive, but yeah, I would have expected something more aggressive than just what looks like an XMP profile and apparently Uncore running at stock. Um, but wait, is he running this on a Venom? On dry ice? Oh wait, that makes this a whole different. That's actually that's impressive. I thought this was on LN2, but this is on dry ice with a Venom of all things. Yeah, that's a Venom LN2 pot. Oh boy. Well, I guess with dry ice, you at least don't have to, because if you tried to run a Venom on a 9980, like, just the Venom is really, really bad for temperature control, because X299 CPUs have a cold bug at around minus 110, and the Venom has a lot of mass put really far away from the actual chip. Like, the way the Venom's weight distribution works out is terrible. The LN2 pot basically, like, it's very easy for the center of the LN2 pot to get hot, while the outside, like, the rest of the pot is still cold. And so when the benchmark finishes, your temperature just comes crashing down. And honestly, it's just the worst LN2 pot for any kind of high heat output cold bug platform, as far as I'm concerned. Like, I tried to run this thing on X99 and it was just an absolute nightmare. So, yeah, but he's on dry ice, so you don't have to worry about that because dry ice doesn't get that cold. But the thing is with dry ice, well, dry ice doesn't get that cold, and a big part what allows you to max out these X299 CPUs is, like, getting them as cold as possible because they run really hot. And yeah, like, if we look at the Benchmate readout right there, this says 33 degrees Celsius max temperature. So yeah, which makes sense. Dry ice is not that cold, and I think that kind of looks like he's got a dry ice soup rather than a dry ice slush going on there. So the thing with dry ice, like the other thing that makes dry ice awkward is you have to use an interface fluid, and if you put too much interface fluid, you end up with worse temperatures rather than good, like, better temperatures. So there's really, like, a sweet spot, and I feel like the Venom probably just is really suboptimal for dry ice as well. Like, the way the internal structure of that LN2 pod is designed is just like, I don't know that you could avoid the whole dry ice soup situation with it very easily. Because, yeah, internally it's basically just a couple of holes, and there's not real, like, those holes are going to have to be full of ice, like, whatever interface fluid you're using, and it's going to kind of screw you over. Well, I guess the Uber bin, the Uber bin of the 9980 XE in that case is a real thing, because doing 5.44, like, doing almost 5.5 gigahertz on dry ice on what I would consider a pretty suboptimal LN2 pot for this kind of setup is insane. Like, doing 5.5 with these chips on LN2 is pretty hard. And then seeing that on dry ice. Well, actually, I guess with 9990 XEs, it should be kind of easy on LN2, but because they're so uber binned. But with the regular 14 cores, this isn't supposed to be this easy. So this, yeah, for dry ice, this is just an insane score. I'm surprised that with dry ice he didn't push the memory further, because the nice thing about dry ice overclocking is that, sure, it doesn't get as cold, and you can't really control the temperature. It just, like, with dry ice, you're just at dry ice temperatures, and whatever the temperature, like, whatever temperature it'll hold is kind of whatever temperature you're stuck with. But the nice thing about dry ice is because you don't have a cold bug. You can't hit, like, on some platforms, dry ice won't work, like Sandy Bridge or something. Well, it's not that it won't work, it'll be really awkward, because the cold bug can be actually in the dry ice temperature range. But with X299, the cold bug's at minus 110. Dry ice is never ever hitting, well, okay, no, that's not true. But without a lot of extra effort, you're not getting dry ice to hit a minus 110 degrees Celsius. So basically, if you're running dry ice on X299, you can just kind of, like, you should basically be able to just fill up the pot and then sit there fiddling with your settings like you're on water cooling, assuming that you've done a good job of insulating your system. So, Yeah, still though, really like it's just cool to see a 99XE actually in action on like sub-zero cooling for once. Um, and yeah, so impressive like like interesting choice from Crazy 85 here on the CPU, and hopefully he pushes it further in the future. I'm pretty sure Crazy 85 has run LN2 benchmarks in the past, so it's gonna nope. Yeah, he has access to LN2. So hopefully it's a matter of time before, well, he might not have access to a better LN2 pod. I'd say still worth trying it. Like it's not going to be fun trying to control a 14 core with a Venom in Cinebench, but it would probably still get you better results than dry ice. Um, So yeah, maybe we'll see him take first place on that 99 for Cinebench 14 core with that 9980XE. I mean 9990XE someday. Because like that is a very strong overclock for dry ice cooling, and you know if you could just run it colder, like it's getting really hot. Um, oh come on. Like it is getting very, very hot, right? Like it says right there, 33 degrees Celsius. Um, so yeah, I think with more cooling, like this, I at least 5.6 or 5.7 should be easily doable. Um, so yeah, but still, congratulations to Crazy 85 on the just second place in 14 core Cinebench R20 with the 9990XE. Very impressive score, especially for dry ice. It's more like impressive to see what these like uber bin 9940Xs can do. Um, Now, if only they weren't so damn expensive and rare. um, Anyway, let's move on to. So, congratulations to Crazy85 on that, and let's move on to the next score, which is Ovis Hardware Labs Y-Cruncher Pi 1 billion score. 14 core Y-Cruncher Pi 1 billion second place on the 10940X on chilled water cooling and doing 4.9 gigahertz on the cores. And so 10th gen HEDT CPUs do clock a little bit better than the 9th gen chips, because basically 7000 series and 9000 series are like the same thing. The 9000 series just added solder instead of thermal paste. But the 10th gen chips are actually slightly improved silicon. So 10940Xs and 10980Xes should on average clock better than like 9940Xs and 9980Xes. And so it's not too surprising to see 4.9 gigahertz from a 10940X. However, man, did it get freaking hot, right? Like 104 degrees Celsius, idle temperature of 13 degrees. So we've got an idle to load delta. I'm pretty sure that chip is thermal throttling at that point. So we've got an idle to load delta of what, 91 degrees Celsius? Yeah, 91 degrees. So an absolutely massive delta there. Memory doing 4000, 14, 14, 14. Y-Cruncher is really heavy on the memory, so you don't really want to be... Like, you can't push the memory as far as you can for other benchmarks. Encore at 3.3 gigahertz. And the thing with Y-Cruncher is just like... It is AVX 512 accelerated, so on the HEDT CPUs, it is insanely power hungry because the Intel HEDT CPUs have full AVX 512 support, and the end result of that is that assuming if you have enough memory bandwidth, like a 10940X at settings like this, I would assume this chip is hitting in excess of 600 watts of power draw, like easily. Because I've had a 7820X at 4.3 gigahertz hit like 360 watts. And this is a 14 core. Now, it's probably a bit more bottlenecked than my 7820X was, but this is also at significantly higher frequencies. So this is just an absolutely insane run of Y-Cruncher, considering like this is what I'd expect from like an LN2 setup. Though I guess with 104 degrees Celsius load, can't be too surprised by that. Running on a Rampage 6 Apex motherboard. And yeah, 7 seconds and 529 milliseconds, so just like a very, very just a very impressive overclock. There's not much else to say about it. Like, Y Cruncher is insanely hot, insanely hard on like your memory and your overall system stability, and so yeah, like I'm surprised this like I'm surprised you can run this on chilled water cooling. I think this kind of frequency is only achievable on LN2 because the world record from Miller is on LN2 at 5.1 gigahertz, and Ova's hardware lab is here at 4.9 on chilled water cooling, and really not even like that far behind. Which that's the thing is like even if you're gonna be like thermal throttling in the benchmark, it's if it's memory like since it can be very heavily thermal like memory starved, even if your CPU clocks are dropping during the benchmark, it's not necessarily going to massively affect the score because you're probably not using all of your clock cycles anyway. Oh, and we don't have a temperature readout for this run over here from Splave, which is a shame. Okay, this has to be thermal throttling a lot, though, because this is 4.9 gigahertz with 4000 CL14, and Splave is over here at 3800 CL12 on 4.7 and getting, like, and the benchmark is pretty skewed towards memory bandwidth rather than latency, because AVX 512 instructions just churn through huge amounts of data very, very quickly. And Splave's really not that far behind, right? Like this is literally like what is that? That's like 5 milliseconds behind. So yeah, I think this is both like this is definitely like I feel like this could be optimized with just lowering maybe the CPU clock and putting more time into dialing in the memory. Like just push the memory clock as far as possible. Which the memory stability can be improved by just making the memory controller get less hot from the cores. But yeah, still a very second place in Y Cruncher is on a any of the HEDT CPUs is just impressive because running Y Cruncher on the HEDT Intel CPUs is just like you thought Prime 95 was hot, and then you run Y Cruncher and it's just like it redefines what high CPU power consumption is, as far as benchmarks are concerned. So yeah, and also it just doesn't appreciate super aggressive memory overclocks. So that makes it a bit more. That also adds to the difficulty of the benchmark. So yeah, I'm a huge fan of this benchmark, and this is a great score here from Ova's hardware lab. Though I really do wonder if that frequency is actually working out for them. Also, the effective clock readout in the benchmate window is only 4.7, so maybe they have like a AVX offset or something going. I wonder if that helps, though. I wonder if that helps. Anyway, still a really impressive score. So congratulations to Ova's hardware lab on that, and let's move on to the next score, which is Crazy 85's Cinebench R15 top score for the Core i5 4670K, 6.1 gigahertz on the Haswell unhyper-threaded quad core on a... Oh, wait, is this on liquid nitrogen? Yeah, this is on liquid nitrogen. Yeah, and he has a Venom. Yeah, I don't blame him for not trying to run the Venom on LN2 with a 9990 XE. Because... based on my person, like I have a Venom, and based on my experience, that has to be that would just be very, very unpleasant to do. But anyway, for something like a 4670K, which doesn't basically pull any power at all, this pot works out really well. So running on a ASRock Z97 OC formula, which I've been told is apparently like one of the best Z97 overclocking motherboards, if not the best, like outright. And what else are we looking at here? Some G-Skill Trident X memory. I'm guessing Samsung D-Die. Yes, it is. So we've got some 2 gigabit Samsung D-Die here doing 2800, 9, 12, 12, 21. 1T command rate, dual rank memory stick, so 8 gigs of memory in total. Like dual rank memory stick, so 8 gigs of memory in total. On DDR3, it was actually completely standard to run dual rank memory configurations, whereas if you look at the DDR4 setups that we looked at, like, this is single rank Samsung B-Die, this is single rank Samsung B-Die, Yep, single rank Samsung B die because of course it is. This is a more single rank Samsung B die. This isn't a CPU benchmark, but you get the idea. So for DDR4, it's really common to be running single rank setups because DDR4 memory controllers suck. No, it's because DDR4 memory frequencies are so high that driving multiple ranks reliably is difficult because the memory controllers suck. Anyway, don't take that too literally. Like for daily, you want dual rank. For benchmarks, a lot of the time you're better off you can push more aggressive overclocks with just one rank on each channel instead of dual rank setups. But on DDR3, because of the lower operating frequencies, it really didn't make much of a difference if you had like one or two ranks in terms of the frequencies that you could hit. But when you had two ranks, you had significantly more performance per clock. And of course, that can very quickly outweigh any, minor memory frequency losses. So, yeah, so for DDR3, it's actually standard to bench dual rank. And the funny thing is, a lot of the late production DDR3 is terrible because a lot of the like 4 gig late production 4 gig DDR3 sticks are very commonly single rank and suck as a result of that because they suck for performance and they also suck in terms of overclocking because the memory chips were worse. But that's not what we're looking at here. This is Samsung D-Die, which is basically one of the best 2 gigabit memory chips for like 2 gigabit DDR3 memory chips there is. Yeah, Uncore doing 5.7 gigahertz, Core doing 6.1, which I believe is probably... I would not be surprised if that was the highest. Actually, not the highest. So some really strong efficiency from Crazy 85 there. As Strat was doing 6.25, so I wonder where the trade-off is. So Strat was on a Gigabyte Z97X OC Force. So this was running with PSC memory, so 2400 812 8. So lower memory latency, but less bandwidth with this overclock. And this is like one of the strongest 1 gigabit DDR3 memory chips ever. I guess part of this is also that Cinebench R15 is like you just have to rerun it a bunch of times to get a top score in it because a lot of the Cinebenches do this thing where the score creeps up as you run it over and over again. So yeah, really like a very efficient score from Crazy 85 here, beating Strax. This actually looks like it might be on Windows XP even, whereas this is on Windows. Actually, no, I think these might both be on Windows 7. I can't tell. This is the small I guess this is the like small taskbar for Windows 7. Anyway, yeah, Crazy 85 managed to beat that score by a whole 9 points while actually being clocked lower, which I'm very impressed by that because Cinebench is the Cinebench is very much a CPU clock benchmark. So yeah, taking first place without actually having to outclock the previous record is very impressive in Cinebench R15. And I get like the only thing I'm seeing is like the memory configuration here, which would kind of make sense, I guess, because this would give you a lot more memory bandwidth, and Cinebench R15 shouldn't really be latency limited. It's a rendering workload, so you would assume that it would use more memory bandwidth than actual latency. So yeah, congratulations to Crazy 85 on the crazy efficiency in Cinebench R15 here because making up a 150 megahertz core clock gap on Cinebench R15 is like that's just straight up impressive. Try to bench some Cinebench R15 and at the top end trying to beat people who are clocked above you without outclocking them is just so difficult. There are a few other examples of that here in the rankings, but actually this is the lowest score relative to clock speed. So let's check out what's going on with that there. Wait, this isn't at 6.3 gigahertz at all. This is at 5.9. So I wonder what happened there. What's Moose 83 running then? So this is another 6.25 gigahertz chip, yeah, which is what you'd expect. Noxinite is at 6 gigahertz with a 957. Their Bauer had a 6.1 and a 939, which I'm guessing No, like that's basically the same memory settings. Maybe just put less time into rerunning the benchmark, because that is a real thing for Cinebench R15 where you just kind of have to sit there and run it over and over and over sometimes. Um, and yeah, like eventually you might get a higher score. That's actually unfortunately a thing with Cinebench R15, but you know, it just also sort of shows commitment. So yeah, this is just a very impressive score from Crazy85 here. So congratulations to him on the Cinebench R15 top score for the i5 4670K. And let's move on to the next score, which is Kubi's GPU Pi for 1 billion top score for the HD7970. 24 seconds, 468 milliseconds on a 7970 push in 1800 megahertz core and stock memory clock, because it's GPU Pi. It doesn't care about your memory clock. Isn't that what a lovely benchmark? Um, Running an MSI HD7970 Lightning, easily identifiable by all the blue LEDs in the VRM area, with some modifications. I guess this is just voltage readout for the memory. I wonder if he has the 0.95 volt. I mean, voltage readout for the core, like core voltage readout, is what I'm guessing that is. I wonder if he has the 0.95 volt rail modded, because that's a big part of running these cards at like really really low temperatures. Um, but yeah, 1800 core on a 7970 is just like that's a very very high core clock. Um, He's really pushing his CPU super hard for. Oh, I guess this. I guess this was like a bigger session where he also probably benched like Firestrike and Vantage. Actually, almost certainly Vantage with 18 cores and 18 threads. Like this is Vantage settings right there, or Time Spy. Like that's Time Spy slash Vantage settings right there. Especially with them. Well, I'm not sure that you would bother benching Time Spy on a 7970 though. Is that very popular or not? Guess we'll find out. Do people bench Time Spy on a 7970? Apparently, yes. To my great surprise. Um, so, yeah. But, like, the CPU here is, like, this is GPU Pi. The CPU is not relevant to the overclock. But still, 1800 core on a 7970 is just a crazy high core clock. But, you know, also kind of what you'd expect in GPU Pi, because GPU Pi is sort of where you get the highest core clocks for GPUs. And so Kubi's takes the top score for GPU Pi by a very small margin. In fact, the 7970s that have been run on LN2 for GPU Pi haven't really been clocked that high. That is, I'm pretty sure there's like actual 3D benchmarks run at higher core clocks than what we're seeing for in the GPU Pi rankings. Because I think Lumi has run his 7970 at like 1850 core for like Vantage or 3D Mark 11. Um, so still though, a like, you know, top score in the ranking, so you can't complain about the results there. Um, that's a 1700 Firestrike. Nope. Where's 3D Mark 11? There. Yeah, 1850 with 1880 on the memory. Um, so I guess maybe it's possible to do like a two. So like if you compare how GPU Pi scales on most other GPUs, I would expect this to do like 1900 potentially if somebody was like really committed to maxing out GPU Pi. Um, Not that I think anybody will be. It's not a particular. Well, at this point, it's 47 points for the benchmark. So yeah, like if you're gonna be doing like a bunch of other 7970 benchmarks, this is definitely a benchmark worth running at this point. Um, And also, like, you know, sometimes it's just fun to see really high, like, impractically high clocks that just crash and everything. Like, GPU Pi to me is kind of the, like, GPU Pi 1 billion, because it's 24 seconds long. It's really not that long a benchmark. Like, this is sort of the equivalent of, like, a CPU Z validation, like, how you take screenshots of FX chips doing 8 gigahertz. Like, GPU Pi is kind of the GPU version of that. Because unfortunately for GPUs, with say AMD drivers, you can set arbitrary core clock without actually having to apply the core clock. And so GPU-Z will quite happily report that you have like a 4 gigahertz overclock if you just set the slider to 4 gigahertz and then never actually hit 4 gigahertz. So yeah, that makes like that sort of makes GPU Pi 1 billion the clock validation benchmark for GPUs. But yeah, congratulations to Kubies on the 1800 megahertz core HD7 970 Lightning here. And the first place in GPU Pi 1 billion on HD7 970s. Congratulations to him on that. And let's move on to the next score, which is Salty Croissant's 3D Mark Time Spy top score for the RTX 2080 Super. Running 2280 core, 2244 memory, card modded to my yeah, like I approve of these mods. This has my approval. I'm not very impressed with the soldering on those multi-layer ceramics over there, and it looks like he accidentally broke a pair of them. But other than that, I do approve of these modifications, especially the like populating because this card, if I'm not mistaken, comes with the polymer capacitor pads in the back. A lot of them are unpopulated, if I'm not mistaken. So yeah, populating those, very much approve of that. He's stacking some capacitors over there. I'm not sure that those are really doing anything for the memory, but hey, it certainly don't hurt. And yeah, so we've just got some light capacitor mods, and then the EVC2 for voltage control on this card. So in the system here, which he's running chilled water cooling, which is why everything is wrapped up in paper towels. You can see the EVC2, the Elmore Labs EVC2 hanging out over there. And basically all that is it gives you a way to communicate with the voltage controller on the GPU through some pretty convenient software. So if if you have a lot of GPUs with digital voltage controllers, which higher end good GPUs do have very frequently, the EVC2 is a super handy utility for just getting voltage control everywhere without like having to do weird stuff to GPUs. Or fighting with like software overclocking utilities that never work properly. So yeah, anyway, we've got a power readout for the system. Apparently it hits 700 watts, which makes sense. Like it's a 2080 Super at minus 10 degrees. He's probably bumping up the voltage quite a bit, because the colder you get NVIDIA cards, the more voltage headroom you get on them. And then the trick to getting a big CPU score in 3D Mark Time Spy is just massive FCLK. Like if you can stabilize, it doesn't need to be 100% stable, just really high fabric clock with just enough stability for the benchmark to still be happy is the trick to getting big CPU scores in Time Spy. And so here we're looking at 2033 Infinity Fabric with 4066, 14, 13, 13, 21 memory settings. 1T command rate. So yeah, this is a single rank Samsung B-die setup. I'm guessing G-Skill Ripjaws? No? Corsair memory of all things. That's cool. So yeah, running on a Asus B550E gaming. So like the cheaper version of the XE that I recently complained about. But, you know, single rank doing 2033 is kind of like, yeah, it's single rank B-die. If the motherboard didn't do that, I'd be super, like, that would be really, really disappointing. But, yeah, 5900X doing 4.724 gigahertz. And then with Time Spy, if you have a 5950X, you actually need to disable the SMT. But if you have a 5900X, you don't have so many threads that you need to disable them. So, yeah, with a 5900X, you actually want to run 12 cores and 24 threads enabled. And that's like that's how you optimize the CPU score in Time Spy, basically, is just mash your FCLK. It also likes memory performance as well, but FCLK really, like, past a certain point, it's way more dependent on getting maximum FCLK rather than maximum, like minimum memory timings or something like that. It's just, yeah. So kind of a wacky benchmark on Ryzen because of that. Yeah, and then for the GPU overclock, I'm like, the 5900X is probably helping quite a bit. 16,000 points is not a low score for a Time Spy CPU test. At the same time, I can't imagine that people haven't run this on X299 CPUs. Yeah, so the 5900X quite handily beats this 10900K. Which this 10900K is very bottlenecked by its memory. So it's worth noting there. The same time, Salty Croissant is also winning on the GPU score, which makes sense. Like, he has the card on chilled water cooling, whereas I'm pretty sure this is... Actually, no, this is also chilled water cooling. It's just not very chilled. Yeah, it's not quite as chilled. Like, Salty Croissant's using an actual water chiller, whereas I guess Harakiri Tiger just put a radiator outside their window in winter. Because that's what this looks like to me. Um, yeah, like, still. Like, I like the mods on the card, and, top score for the 2080 Super ranking, so good job to Salty Croissant. Again, he's a very regular feature of the roundups, which makes sense. I like modded cards, and I like GPU benching, so he ends up in a lot of the roundups. Congratulations to him on the score, and let's move on to the next score, which is Shaggy SVK's W Prime 32 million top score for the Intel Pentium 4 3.2 gigahertz Northwood CPU, doing 5.167, 5,167 megahertz. W Prime is a multi-core benchmark, and the 32M variant on modern hardware lasts a couple of seconds. On a Pentium 4, it takes 44 seconds, and that's if your Pentium 4 is very, very fast. So unfortunately, this is way too old. Like, honestly, LGA 775, I kind of know some things about. Like, I know what the socket is called. I know you can put Xeons into it if you mod them, and it's DDR3. It has a North bridge, and you can also get 775 with DDR2. But this right here, I do believe, is pre-LGA 775. Yes, this is socket 478. I don't know anything about socket 478. Wait, this is a single-core CPU with hyperthreading? Oh, right, because it's the Pentium 4. Right. This is one of, like, the earliest hyperthreading CPUs, right? I'm pretty sure it is. Yeah, unfortunately, this stuff's way too old for me, so I have no idea what's going on here. We've got DDR in single channel. Did they even have dual channel back in the day? No, I see one stick, so I guess it's single channel. And the thing is, W Prime 32M really doesn't care about memory, so... on modern platforms, it doesn't care about memory. I'm not sure if it doesn't care about memory on a Pentium 4, but I'm guessing it doesn't. I mean, we could probably check some scores for reference. This is also single channel. Don't tell me these just didn't have dual channel. No, this is dual channel, so they did have... Wait, this is DDR2. I am confused. This is a problem. This stuff's too old. I have no idea what I'm looking at. Oh, right, because the North Bridge was still built into the motherboard, so if you had a DDR2 motherboard with the right socket, you could just plug in the CPU and have DDR2 on it. Well, anyway... Yeah, Pentium 4 running W Prime. It takes 44 seconds, which, like, at least it's not 1024M, which I imagine takes, like, forever. Like, I guess the main, like, at the end of the day, we can always resort to just looking at the core clocks, because the core clocks are nice and simple to understand. And this is a, like, 200 megahertz increase in the over the highest clock that this benchmark has been run with in the past, I think. Yeah, well, no, Wittix did almost 5.1 at one in the past, but yeah, Shaggy SVK managed to push that Pentium 4 to the highest frequency of anybody who's run one of these Pentium 4s in W Prime 32M so far. So, that alone, I think it's that alone is just like, yep, I understand clock speeds. That is more overclocking than everybody else. Though, wait, this CPU is literally called 3.2 gigahertz. Does it not come stock at 3.2 gigahertz? It does come stock at 3.2 gigahertz. And the average, okay, well, yeah, so it's an impressive overclock. I guess these just didn't clock that high. I thought Pentium 4s were like when Intel decided that clock speed is the most important thing ever. And I was kind of expecting more. I guess it's only the later Pentium 4 based. Are they Pentium 4 based? I don't know. Like, this is too old. I literally don't know. Anyway, yeah, an impressive overclock from Shaggy SVK here. It's just, I have no idea what's actually going on with it because the hardware is so damn old, but Like, the clocks are evidently way higher than everybody else before him. So, congratulations to him on that. And let's move on to the next score, which is Kepi 1475's 3D Mark 11 Extreme second place on the GTX 570 Classified. Now, you might think this is some crazy custom PCB from EVGA, because that's normally what classified cards get. Nah, this is just a GTX 580 PCB. Like, the thing is, a reference GTX 570 comes with a four-phase variant of the GTX 580 PCB. This comes with the 6-phase variant of the GTX 580 PCB. And the difference between the 4-phase and the 6-phase version of the GTX 580 PCB is that they basically don't populate 2 of the phases normally. So this is just a fully populated GTX 580 PCB in terms of the VRM. The memory chips are missing because that's one of the defining differences between a GTX 570 and a GTX 580, is the missing memory chips. And like 1120 core on a Fermi card is hard to do. Like that's a bit, like, that's a lot of core clock. And then 1250 on the memory, I actually don't know because I haven't, like, I like Fermi, but I don't remember what kind of memory clocks it hits. So actually that's a really high memory clock as well. And then we have some people reporting, I think, effective clocks. But yeah, so, like, impressive core clock right there, impressive memory clock. Cards heavily modified. We've got, like, a serious power bridge going on. And actually, if I remember correctly, this PCB on, like, stock voltage drops like 50 millivolts going from the VRM to the core. So this is actually not a terrible idea. At the same time, I don't think those cables are thick enough. Like, I've done this myself. I've done power bridges with 18 gauge cables, and my current verdict on doing that is not really worth it. Like, it doesn't hurt anything, so I guess, if you have the time and you're feeling bored, go ahead and do it. But I have finally managed to find something that does a good job of power bridging GPUs, and, like, it's like, basically you need to use, like, not, like, you'd basically have to use like 10 or 12, 19, like 18 gauge cables to achieve the same effect. And this is 6. But still, like, we've got extra caps, we've got a power bridge going on, we've got some voltage monitoring up there. I'm assuming there's a potentiometer hanging out somewhere, or is this just on an EVC? Actually, no, we do have potentiometers. They're hiding on the edge of the card right there. Not that much V-Corp. Actually, no, this is Fermi. Fermi has a really low V-Core. For being a 45 nanometer GPU, you'd think it, like, runs at some really high voltage relative to modern GPUs, but no. A lot of Fermi cards actually run at less voltage than modern GPUs because of just how insanely power hungry they were. And NVIDIA's only solution to reining them in was just like, well, we're just going to undervolt them from the factory a lot. And so, yeah, that makes the 500 series pretty fun, because there's a bunch of voltage headroom left on them because, yeah, they didn't feel like shipping 500 watts, 400 watt cards from the factory, so you get to turn the cards up to 400 watts yourself, instead of what we get today, which is the card comes at 400 watts from the factory and you can turn it up to 800. Well, no, more like 600, but still. Yeah, so just a nice solid, GTX 570 overclock supported by a Ryzen 5 3600, which, actually getting, how everybody gets a better I suck at 3D Mark. A Ryzen 5 3600 can get 20K in 3D Mark 11 physics? Really? Man, I suck at 3D Mark so bad. Like, 3D Mark 11 physics, I suck at it so bad. Like, so bad. Anyway, solid combined score, GPU score. Like, the CPU is a little bit overpowered for the GPU here because the GTX 570 is just so damn old. And we've got an ASRock B550 Steel Legend here, 3600 doing 4.7 gigahertz. So this is a good 3600 there. 3733 CL14 on the memory, so, taking it pretty easy on the memory settings, but you don't have to go, well, 3D Mark 11 does like memory, memory timings for the physics score, but your GPU is putting out 2,700 points GPU score. You don't really need more physics score in this kind of scenario. So time is better spent dialing in the GPU rather than the memory, though I guess if you have time to spare, you could also just push the memory even further. As how close is Kepi here to beating Char? Actually, really far away. So yeah, that wouldn't have really made up the difference. That makes sense because Char was on Char was on dry ice and only hitting 1130. So Kepi's got a really, really good card. Or Char was on a reference PCB and actually there's a pretty decent, that looks very reference. So this probably has the 4-phase variant of the VRM. And if I'm not mistaken, they didn't even fully populate the output filtering on those. So yeah, just a very, very solid score here from Kepi in 3D Mark 11. Though Char has a significantly better GPU score. I wonder if that's down to LOD. Does Char have... I'm looking for NVIDIA Inspector. I'm not seeing NVIDIA Inspector. There's Oh wait, no, he does have NVIDIA Inspector. Yeah, and also D3D Overrider, but NVIDIA Inspector, because the thing is, for 3D Mark 11, which I think if we have a validation, we don't have a validation link, which is a bit unfortunate. Do we have a validation link for Kepi's score? I don't even know if they track that for 3D Mark 11, now that I think of it. But basically, so for a lot of the older 3D Marks on NVIDIA GPUs, what you can do is you can change the level of detail, and that basically just tells the GPU to render the benchmark with less detailed textures. And with less detailed textures, you get more FPS. And that's totally valid for HWbot rankings. It's not valid for the 3D Mark rankings, but HWbot rules are different from 3D Mark rules because just because of the priorities that HWbot has for their score database versus the like 3D Mark's database. The goal there is to make like a score data. Well, like it's just different priorities. We'll leave it up. Like I'll probably do a video explaining how HWbot works and explain why it is that HWbot allows things like turning off tessellation and fiddling with your texture quality. Well, using LOD to mod the texture quality and that kind of thing in that someday. So yeah, anyway, still a very like that's a crazy high core clock for a GTX 570 on water cooling. I mean, it is not very well, 20 idle, 15 ambient, so I guess like it's getting cold. So well, actually no, I'm buying. Where's Kepi? I don't recognize that flag. That's Austria. Oh, yeah, okay. Well, if he's in Austria, then I imagine getting 15 degrees Celsius ambient isn't too difficult. So, yeah, you don't need a chiller. Just live someplace cold and you don't need a chiller anymore. So, yeah, an impressive score from Kepi for the GTX 570. And yeah, I think honestly, like mess around with LOD, maybe fiddle with the memory timings a bit more to further boost the physics score. And yeah, just a really solid GTX 570 score there. So yeah, that is it for this week's HWbot score roundup. It actually isn't stupid long, and mostly because we only have 10 scores for once. So yeah, congratulations to everybody who's gotten like top scores. Obviously, I didn't include every top score that there was. I just sort of made a selection of my personal favorites, which obviously heavily skews towards GPU benchmarks. Yeah, as well as just more modern hardware in general, and also a lot of X299, because X299 is really underappreciated. For a pretty decent reason, but like it's still underappreciated in my opinion. Like it's a cool platform. It's not necessarily a great platform, but it's cool. And I prefer it to Threadripper, because unlike Threadripper, it's actually good at Firestrike. Anyway, yeah, that's it for this week's HWbot score roundup. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There is a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check them out. And that is it for the video, so thank you for watching, and goodbye.